My project topic is homology. Now we are going to see about homology. Introduction. In mathematics, homology is a general way of associating a sequence of algebraic objects such as algebraic group or modules to other mathematical objects such as topological space. Homological group were originally defined in algebraic topology. Homology എന്ന് പറയുന്നത് എന്താണെന്ന് വെച്ചാൽ സീക്വൻസ് ഓഫ് അൽജിബ്രോയിക് ഒബ്ജക്റ്റിനെ ടോപ്പോളജിയുടെ കൂടെ കണക്ട് ഇത് പറയുന്നതാണ് homology എന്ന് പറയുക. The original motivation for defining homological group was observation that two spaces that distinguished by examining the whole. ഇതിൻ്റെ ഒറിജിനൽ മോട്ടിവേഷൻ എന്താണെന്ന് പറഞ്ഞാൽ രണ്ട് ഷേപ്സിനെ ഹോൾസിൻ്റെ കൂടെ എക്സാമിനിങ് ചെയ്ത് എന്താ കിട്ടുന്ന നോക്കുന്നതാണ് ഹോമോളജി. ഫോർ എക്സാമ്പിൾ, സർക്കിൾ ഇസ് നോട്ട് എ ഡിസ്ക് because a circle has a hole through it, while the disk solid and ordinary sphere is not a circle because the sphere is enclosed in the two-dimensional hole while the circle is enclosed in the one-dimensional hole. However, because the hole is not there, it is not immediately obvious how to define a hole on homology to distinguish different kinds of hole. Then we are going to see about types of homological space. Chapter 2. Types of homological theory. The different types of homological theory arise from the functional mapping from various category of mathematical object to the category chain complex. In each case, the composition of functor from the object to the chain complex and the functor from chain complex to homological group defines the overall homological functor for the theory. There are 14 different types of homologies. Now we are going to see about simplical homologies. n സിംപ്ലെക്സിന് ഡെൽറ്റ എന്ന് ഡിനോട്ട് ചെയ്യാണ്. ഈ ജോമെട്രിക്കൽ ഫിഗറിൻ്റെ കളക്ഷൻ n+1 പോയിൻറ്റ്സ് ആവും ഇൻ ഈക്വലേഡിയൻ സ്പേസിൽ. മൂന്ന് എക്സാമ്പിൾസ് ഉണ്ട്. 0 സിംപ്ലെക്സ്, 1 സിംപ്ലെക്സ് ആൻഡ് 2 സിംപ്ലെക്സ്. 3 സിംപ്ലെക്സ് ഇസ് ടെട്രാഹൈഡ്രൺ, ഓൾസോ നോൺ ആസ് എ ട്രയാങ്കുലർ pyramid. Next definition. n സിംപ്ലെക്സിൻ്റെ ഡയമെൻഷൻ ലെസ് ദാൻ n ആണെങ്കിൽ അതിന് പ്രോപ്പർ ഫേസ് ആണെന്ന് പറയും. 2 സിംപ്ലെക്സ് ആർ സെഡ് ടു ബി പ്രോപ്പർലി സിറ്റുവേറ്റഡ് ഇഫ് ദർ ഇസ് ആൻ ഇൻ്റർസെക്ഷൻ ഇസ് എയ്തർ ആൻ എംപ്റ്റി ഓർ എ ഫേസ് ഓഫ് ബോത്ത് സിംപ്ലെക്സ്. രണ്ട് സിംപ്ലെക്സിനെ പ്രോപ്പർലി സിറ്റുവേറ്റഡ് എന്ന് എപ്പോഴാണ് പറയാമെന്ന് വെച്ചാൽ അതിൻ്റെ ഇൻ്റർസെക്ഷൻ ഒന്നെങ്കിൽ എംപ്റ്റി ആവണം അല്ലെങ്കിൽ ബോത്ത് സിംപ്ലെക്സ് ആവണം. We are going to see about an homological group. An orientation of n simplex indicate n-1 faces. There is an example of 2 simplex is given in an orientation with which indicates a face, one face. Then we are going to see this definition declare that an each orientation simplex is equal to a negative simplex with opposite orientation. For example, v0 v1 is equal to minus v1 v0. Then set of n chains from a abelian group under addition. Example, calculate delta into delta the whole square. Then there is one definition. We call n chain cycle of its boundary is 0. Denote the set of n chains k over z. Zn into zn is a subgroup of n. Can be written as zn is equal to kernel of delta. Then there is one definition. N cycle x of k complex is homologous to 0. A boundary is then a cycle that is homological to 0. Okay. There is example for that definition. Next, a group Hn in the n-dimensional homological group is a k over z that is written in kernel of delta by image of delta. Next we are going to see one definition. N skeleton, the set of all simplex in a complex k with set of all simplex in a complex k less than a dimension less than or equal to n ആണെങ്കിൽ അതിൽ n skeleton എന്ന് പറയും. n skeleton എന്താണെന്ന് വെച്ചാൽ സബ് കോംപ്ലെക്സ് ആണ്. നെക്സ്റ്റ് ഡെഫിനേഷൻ, ഒരു കോംപ്ലെക്സ് കെയിനെ കണക്റ്റഡ് ആണെന്ന് എപ്പോഴാണെന്ന് പറയാമെന്ന് വെച്ചാൽ ഡിസ്റ്റൻറ്റ് യൂണിയൻ ഓഫ് 2 or more നോൺ എംപ്റ്റി സബ് കോംപ്ലക്സിനെ cannot be represented റെപ്രസെൻറ്റ് ചെയ്യാൻ പറ്റാത്തതിലാണ് അതിനെ കോംപ്ലക്സ് കെയിനെ കണക്റ്റഡ് ആണെന്ന് പറയുക. ജോമെട്രി കോംപ്ലക്സ് வந்து പാത്ത് കണക്റ്റഡ് നമ്മൾ എപ്പോഴാണ് പറയാന്ന് വെച്ചാൽ ഇഫ് ദർ എക്സിസ്റ്റ് എ പാത്ത് ഒരു പാത്ത് ഉണ്ടാവണം ഓഫ് വൺ സിംപ്ലെക്സ് ആകുന്ന പാത്ത് ഫോർ എനി വേർട്ടെക്സ് ടു എനി അതർ എനി വേർട്ടെക്സ് ടു എനി അതർ. നെക്സ്റ്റ് ക്ലെയിം എന്താണെന്ന് പറയുന്നത് വെച്ചാൽ എ പാത്ത് കണക്റ്റഡ് ഇഫ് ആൻഡ് ഒൺലി പാത്ത് കണക്റ്റഡ് ആണെങ്കിൽ അത് കണക്റ്റഡ് ആവണം. നെക്സ്റ്റ് അതിൻ്റെ പ്രൂഫുണ്ട്. നെക്സ്റ്റ് തിയറം, നെക്സ്റ്റ് ഇതും റിലേറ്റഡ് ആയിട്ടുള്ള ഒരു തിയറംസ് ആണ്. Next we are going to see about singular homology. A definition of singular homology. Given a topological space X, a singular n simplex in X maps to sigma from delta raised to n to X such as delta continuous ആവണം. നെക്സ്റ്റ് ഡെഫിനിഷൻ എന്താ പറയുന്നത് വെച്ചാൽ ലെറ്റ്സ് എൻ ഓഫ് എക്സ് ബി എ ഫ്രീ എബിലിയൻ ഗ്രൂപ്പ് വിത്ത് ബേസിസ് ദ സെറ്റ് ഓഫ് singular n simplex of x. The element of Cn of x is called singular n chain and a finite forms of summation I gi sigma I where gi belongs to z. Next, another one definition, a singular homological group Hn of x is defined in a quotient group in എങ്ങനെ ഡിഫൈൻ ചെയ്യാന്ന് വെച്ചാൽ Hn of x is equal to kernel delta n mod image of delta n plus 1. Then the related propositions and theorems are there. Next we are going to see about chapter 3, a chain complex, extract sequence and related homological groups. A chain complex is a sequence of abelian group connected by homomorphism such as a composition of two consecutive map is 0. Composition of two consecutive map is 0. A group Cn of x is singular n chain from a chain complex with a boundary operation delta n. Next we are going to see about one definition. The homological group of a chain complex are given by kernel delta n mod image delta n plus 1. Next definition, a chain map f between two complexes a delta a b delta b is a collection of map function fn from an to bn such that f computes with an operator delta a and delta b in the following diagram. Next theorem, a chain map between two chain complex induced homomorphism between homological group. A chain map between two chain complex induces homomorphism between homological group. Next definition, a sequence of the form an plus 1 to an to an minus 1 where ai's are the abelian group, alpha is in the homomorphism, ai's abelian group ആണ്, alpha a homomorphism ആണ്. അതിനെ extract sequence എന്ന് ഇപ്പോൾ പറയാന്ന് വെച്ചാൽ kernel of alpha n is equal to image of alpha n plus 1 for all n. We know two things we have to note. Kernel alpha n is equal to image alpha n plus 1. This implies image alpha n plus 1 is equal to kernel alpha n if and only if alpha n into alpha n plus 1 is equal to 0. So the extract sequence is a chain sequence ആണെങ്കിൽ extract sequence chain sequence ആണ്. Kernel alpha n contained in image alpha n plus 1. The homological group of an extract sequence or trivial. Homological group of an extract sequence or trivial. We can express some algebraic concept using extract sequence. 0 to a to b is an extract if and only if kernel a is equal to 0 or a is injective. A to b to 0 is extract if and only if image of a is equal to 0 or a is surjective ആണ്. 0 to a to b to 0 is extract if and only if a is isomorphic ആണ്. 0 to A to B, B to C, C to 0 is extract, 0 to A to B, B to 0 is extract if and only if A வந்து isomorphic ஆகணும். 0 to A to B, B to C to 0 is extract if and only if A injective ஆகணும், B surjective ஆகணும், and kernel of B is equal to image of A ஆகணும், which is in which case B gives an isomorphism to C isomorphic to B by image of A. If A subset of B is an inclusion, we have C isomorphic to B by A. This type of extraction is called start extract sequence. E types of extraction is extract sequence ആണെന്ന് പറയും. Next concept relative homological groups. ഒരു സ്പേസ് എക്സ് എടുക്കുക, അതിൻ്റെ സബ്സെറ്റ് എ, സബ്സെറ്റ് ഓഫ് എക്സ് എടുക്കുക, we define Cn of x, a to be a quotient group. Cn of x, a നെ quotient group ആയിട്ട് ഡിഫൈൻ ചെയ്യുമ്പോൾ Cn of x by Cn of a. This means that chain in A gets identified with the trivial chains in Cn of x, since the operator delta from Cn of x to Cn minus 1 of x. Also take Cn of A to Cn minus 1 of A, we get a natural boundary map quotient group delta from Cn of x, a to Cn minus 1 of x, a. Then the given sequence, which can be a chain complex, because delta n plus 1 delta is equal to 0, we can define a relative homological group Hn of x, a to be a homological group in chain complex. The two important facts about Hn of A are element in Hn of A are represented by relative cycle. Element of Hn of A represented by relative cycles are n chains of n chain x in Cn of x such that delta n x is equal to Cn minus 1 of A. A relative cycle x is trivial if and only if its a relative boundary, that is x is a sum of chain in Cn of A and the boundary of chain in Cn plus 1 of A. The next relative homological group Xn of x, a fit into a long extract sequence constructed in this diagram. In this diagram, I is an inclusion map. Cn of a subset of Cn of x. J is an quotient map Cn of x to Cn of x, a. The diagram is commutative. We return to a 90-degree to get it in this form, where columns are start extract sequence and the rows are chain complex abelian group Ai, Bi and Ci. I and J are chain map indicates a map I and J star on homology. We take some C belongs to Cn be a cycle, J is surjective ആണ്, C is equal to JB for some B belongs to N. For delta B belongs to Bn minus 1, J of delta B is equal to Sj. Delta J of B is commutative. Then delta J of B is equal to delta C is equal to 0. C cycle ആണ്. അപ്പോൾ delta B belongs to kernel J. Since the column are extract, kernel J is equal to image I. This means that delta B is equal to I of A for some A belongs to An minus 1. Commutativity gives I into delta A is equal to delta I of A. This implies delta into delta is equal to 0. So I is injective. This implies delta A is equal to 0. Therefore A is a cycle represents the element A belongs to Hn minus 1 of A of homology. Next we are going to see about well-defined for the following reasons. I is injective, so A is uniquely determined by delta A. I injective ആണെങ്കിൽ A is uniquely determined by delta A. But B dash choosing B dash instead of B gives choosing B dash instead of B, then doing some calculation, we get delta A dash equivalent to 0. So A plus delta A dash equivalent to A. Choosing C star from the quotient of C implies C star is equal to C plus C dash. C dash is equal to J of B dash from some B dash. Then we are doing some calculation. Thus C changes has an effect of changing B to the homological element, which does not affect A at all. Then the related propositions and theorems are there. The map delta from h raised to n to c to h raised to n minus 1 to a as defined in the homomorphism. Then there is a proof and related propositions and theorems. In order to show the equivalence of hn of x and hn delta of x, we need to show the existence of an isomorphism between the two groups for all n. It is enough to see that the existence of homomorphism. We have already know the mapping ln of x to cn of x from simplical chain group to the singular chain group. We sense each simplex x to delta from delta raised to x to sigma from delta raised to n to x. This includes a map hn of delta of x to hn of x. We can proceed with simplical and singular homological group of a delta complex are always isomorphic. Okay. Then theorem. For all n, the homomorphism hn of delta of x to hn of x are isomorphic. Thus the singular and simplical homological group are equivalent. Then we are going to see one lemma in commutative diagram is of the form alpha comma beta comma gamma are all isomorphic. Then the two rows are extract and gamma is also isomorphic. We have to show first. We have to show that gamma is surjective. Then we have to show gamma is injective. Then we can get B is equal to I of A, C is equal to J of B equal to J of I of A is equal to C by extraction of row. Hence gamma is trivial kernel and is injective. Applying this to the earlier diagram, we note that arrow hn delta of x k x of xk implies to hn of xk must therefore be an isomorphic, and so the theorem is proved. Then we are going to see about chapter 5 and applications of homology, application in pure mathematics. The borrower's fixed point theorem. If f is any continuous map from a ball b raised to n to itself, then there is a fixed point a belongs to b raised to n with f of a is equal to a. In next invariance of domain, if U is an open subset of R raised to n, f is an injective continuous band, then V is equal to f of U is open and f is a homomorphism between U and V. The Harry-Bolt theorem, any vertex field on two sphere vanishes at some point. Then any continuous function from an n sphere into Euclidean n space maps some pair of antipodes point to some point. Two points on the sphere are called antipodal if they are exactly opposite direction from the sphere's center. Invariance of dimension, if non-empty open subset U belongs to R raised to m, and V belongs to R raised to N or homeomorphic, then M is equal to N. Next we are going to see about applications in science and engineering. In data analysis, data are recognized as a point in manifolds. Manifolds are algebraic variety of embedded Euclidean space. Then in sensor network, sensors may communicate information via an ardoic network that dynamically change in time. In global content of these sets of local measurement and communication path, it is useful to compute the homology of the network topology to evaluate, for instance, holes in convergence. In system theory in physics, the Poincare was one of the first to consider the interplay between invariant manifolds of a dynamical system and topological invariant. Morse theory relates a dynamic of gradient flow of manifolds to its homology. Floor homology extends its infinite dimensional manifolds. The KAM theorem established the periodic orbit. In particular, they may form a baths that can investigated using floor homology. In one class of finite element method, boundary value problem for differential equation involving Hodge's Laplace operation may need to be solved on a topological non-trivial domain, for example electromagnetic stimulation. In this stimulation, solution is added by fixing the cohomology class of solution based on chosen boundary condition, the homology of domain. Fem domains can be triangular from which the simplical homology can be calculated. Thank you.